Hi everybody, and welcome to CoderDojo Ham's April live stream. It's lovely to be back on the air. We've got a fantastic program for you this afternoon. So I'll hand straight over to Richard to introduce facial recognition stuff and prototyping with Scratch. So Richard, over to you.
Hi everyone, welcome to the session. I'm just going to wait for a few seconds while people join in because we're spot on time. If you are watching live, why not say hello in the chat and just say where you are and what you've been up to. Say hello to us all. Yeah, I can see some people already in the chat there. That's great. As Peter said, today I'm going to be doing some face detection stuff with Scratch. This is some new capability that's been added into Scratch as part of their labs setting. So this is where they try out new stuff before they add it into the main Scratch system that you can use. So if you've got your own Scratch account, you won't be able to save any projects we do with the face sensing stuff today to your Scratch account. You can still save them, you just have to download them to your computer. And I'm going to show how to do that as we go along. So I hope you're all ready to go and looking forward to playing around with this. I haven't spent a lot of time with it, so I'm going to be experimenting along with you and to see what we get on and can create. So first thing we need to do is we need to go to the URL on the screen there. So it's lab.scratch.mit.edu/face. So that's lab.scratch.mit.edu/face. I'm just going to share my screen now and show you what that looks like. There we go. When you go to that URL, lab.scratch.mit.edu/face, that's what you should see. And you can see it says up here, this is a lab. We're trying out experimental blocks that the Scratch team is exploring. So I think this is really cool, and I'm expecting it to end up in the real Scratch as a plugin sometime soon, but you never know. They might decide not to do it, in which case we'll have been lucky to give it a go there. If anyone's got any problems going to that URL, let me know, but otherwise I'm going to assume you're all there now. I'll leave the URL on the bottom of the screen here so you can see it, and for people who join late so they can get there as well. But when you're on this page, basically you just click on the button that says try it out. And there we go. And now you can see immediately it's switched on my webcam. So now, you lucky people, you get to see two views of me, one on the left here, one on the right. I'm hoping this will start, that will start moving too. Yeah, so look, I can wave, and weirdly, it's the mirror image. So that's something to bear in mind there. And you can see straight away, it's on the left-hand side, it's loaded in these new blocks, the face sensing blocks. And we're just going to have a play around with some of those to start off with. The first thing we can do, like at the moment, I've got the cat in front of my head. So I'm going to try and do something more useful with the cat. One of the things that really made me laugh early in the year, and you may have seen it, was there was a very important legal meeting in America. And one of the lawyers who joined the meeting was using, I think, someone else's computer, and they had a filter set on so that he looked like a cat. And he was saying, look, I'm not a cat. It's really me. I'm here live. And that made me chuckle. So I thought we could have a bit of fun, seeing if we can make our own filters to use today using Scratch. So first thing I'm going to do, I'm going to go into the costumes here. I'm just going to delete this one, and then I'm going to add in a new costume. I'm just going to draw one myself, I think. I'll try and do that. Those of you who are hoping to see Ozzy here today, unfortunately, he had another appointment, so it's just me doing it today. I will definitely miss Ozzy's artistic talents. So I'm going to try and just draw myself a little face. I'm going to click on the oval, and then, oh, looks like purple selected, so I'm going to have a purple face. That's okay. That sort of face shaped. I'll select a different color. What color eyes shall I have? I want to have green eyes. Oh no, that's made the whole thing green. Okay, I'm going to have a green face then. That's cool. Let's do that again. I'll select here, and then I'll give myself some blue eyes. and put those on there. That's about right. Do another one. Oh, they're not really the same size. That's okay. There's nothing wrong with a bit of asymmetry. For the nose, maybe I'll try and do a freehand nose there. There we go. Okay, that's not super good, is it? And a mouth. Let's give myself a bit of a yellow mouth. Okay, and I probably need some eyebrows. People look weird with their eyebrows, don't they? And some ears. So let's go back and get some green again. My ears should be the same color as my head. Oh dear, they're quite ridiculous ears, right? Never mind. Okay, so there we go. So we've got a little face there, which we can use, and I can try and put that on as like a mask. So if I go back to my code, first thing we need to do, as ever with Scratch, is we'll get a when green flag clicked pulled out, and then we'll also, I'm going to need a forever loop. So I'll drop that in there right now. Let me just make my things bigger because I don't know if I can see them. Hopefully that's big enough. If you need them bigger, just shout out in the chat. I can always make that bigger. And then we'll go back to the face sensing blocks, which you can see are down the bottom here. And I'll grab that. And I'm just going to pick go to nose. So when I click that, that should now make this head go to where the face software thinks my nose is. So let's see if it's working. Oh, look, straight gone on there. Okay, look, and now look, I move my head and the little thing moves. It sort of works, but it's just stuck on my nose. So let's see if we can make that better. One thing I found is there's this block here, which is set size to face size, which tries to work out what size the mask needs to be to match your face. So I'll just drop that in. Now you can see if I move my head back, the mask gets smaller, and if I come closer, the mask gets bigger. So that's kind of working okay. I'll tell you what's messing it up. Look, can you see here on this bit of the screen, I've got a blob in my costume. Let me go back and edit my costume. Oh yeah, look, I made a blob over there. That's what's messing everything up. Let me erase that. That should be better now. That's not bad. I think if I also edit my costume and maybe change the center of the costume a bit. So if I highlight everything and move it up a little bit, highlight everything, and then drag all that up. So you've got, remember the little crosshairs here that shows you where the center of the costume is. If I make that there, that's now more central on my face. So it moves around. Just if I move my head really quickly, I think because my camera's feeding two streams, it moves quite quick. There we go. We've got a really simple mask there. That kind of works. I think we can probably do better with some kind of costume. So I'm going to detach that from there for now. I'll leave that head in there. I'll stop that and then just move that out of the way. Let's see what else we can do with some filters. So I quite like the idea of, rather than just having one big mask, having some sort of costume stuff around me, a bit of a disguise. So what I'm going to do is I'm going to add in another sprite, and I'm going to just find a sprite because I know that in Scratch there's some good stuff. Let's go for, if I look for glasses here, there we go. Yeah, look, there's this glasses sprite. There's a whole bunch of different glasses in, so I'm going to add that one in. Use that, and there you can go. You can see I've got some glasses on the screen there, and in the costumes there's a couple to choose from. Let's pick those because they're quite easy to see on screen. And then I'm going to go in and put in very similar code to that what we did before. So I'm going to get a when green flag clicked. I'm going to get a forever block, and then I'll go back in here and I'll put, this time, instead of going to nose, if you have a look in this drop down, there's all different bits of your face that it can recognize. So I'm going to send this to between my eyes. So I did put those there. And I'll also add in that thing that was useful, set size to face size again. When I click green flag, there we go. Look, I've got some nice, cool glasses. That's pretty good. So there we go. That's one simple one working in there. There's another thing you can add in here, which is this, which is point in the direction of face tilt. So basically, the Scratch can detect when I'm tilting my face moving it around. Let's see when I tilted my head there, it didn't really work. Now I've added that block in. Let's just restart. I turn my head. There you go. They can. If I put my head at an angle, they've tilted a bit of an angle as well. So that's doing a better job of doing that before. So we got some glasses. That's pretty cool. Let's add in some other stuff. Let's pick. We could do hats. So look at hats. Hats. All right, nice. We got that's got a range of hats in it. It's a hatchling. Party hats. I like the boppers in here. So I think I'm going to add that in as well. And then for the code for the let's just check. I quite like these boppers. So I'm going to pick that one to start off with. And then what we can do here, I don't need to do any code. I'm just going to grab this code and drag it onto the party hats sprite, and that should copy it across there. And then I just need to make sure I've clicked on the party hats. I don't want these things to go between my eyes. I want them to go onto my top of head. There we go. So that should be up here. Let's click that, see what happens. Oh, there we go. Yeah. Now again, look, that's not quite the top of my head, is it? That's in there. So let's see if we can make that better by adjusting the costume center. So where's the costume center there? If I select the whole thing, yeah, it's quite high up. So if I make that up a bit, there we go. Look, that's now jumped up to the top of my head. I think that should be better in terms of keeping them on my head. Yeah, there you go. Look, nice. And the fact that we've got all these different costumes in here, it'd be quite nice if we wanted to change our disguise very quickly. We could just click on the particular bit of the costume and make it change. So let's just add in here a when this sprite is clicked, we'll go to looks and we'll get a next costume. Okay. So let's just run that again. So now when I click on the thing, I can change my hat. Oh, see, that hat's too low. So let's go back in here again. We'll do the same thing. We'll grab the costume, move that up a bit more maybe. There you go. That's cool. That's on top of my head. And then if I click on that other costume also needs raising up a bit. Obviously, if you were drawing your own costumes, you could make sure you had the center back right. Great, there we go. So let me just make it full screen so you can see it for a minute. So there we go. If I click on here, I can swap and get on my funny alien head there. And all it's the same for the sunglasses, right? It's the same for sunglasses. So if we go from the code, I can just do the opposite this time, and I'll drag that onto the sunglasses code. So when I click on my sunglasses, oh, let's just stop that, rerun it. Did that go in there? It missed. Let me try again. Why is that not dropping it in there? Oh, let's just stop running everything and do it. Actually, I'm just going to create it. I think it's because my computer's running a bit slow. When this sprite clicked, next costume, there we go. And yeah, I'm going to go full screen again, and I've got nice. That's working quite well there. Maybe not with the ears and the hat on. And if I lean back, it gets smaller, and I come in nice and close and get a big bunny head on. I like that. That's nice. Right, what else can we add in? So we've got glasses, we've got something on the top of my head. What other options have we got here? We've got mouth, left eye, oh, ears, right, ears. Let's see if we can put in some ears. That might be interesting. Have we got anything? Have we got any ears in the Scratch costume? I don't think we have. We've got a bear, that's not going to help. Oh, I know what we could do. I think if I look for elephant, yeah, there we go. The elephant has got some big old ears on him. So if I add in the elephant sprite, and then let's go and edit his costume. Which one's got? I think let's delete that one. He's got some nice ears here. And the great thing about Scratch 3 is all the individual elements of the costume are clickable. So I can grab on his ears, pull that out there. I suppose I could try and give myself a trunk as well at some point. Let's just stick with ears for now. I'll delete all the rest of it. And then I'll put that in. That's a left ear, isn't it? So if I make that just to the left of where the target is, I'm just going to help myself out by renaming it left ear. There we go. And then let's add some code in for that. I'll have when green flag clicked forever. I want to go to left ear. Now I don't know how this is going to work, so I've got big headphones on, so hopefully it will know roughly where my ears are based on that. I'll also have the set size to face size and point in the direction of face tilt. Let's just click on that. And yeah, oh yeah, I've got one ear on. That's okay. I think maybe if I edit the costume, I'll bring the ear a bit closer to the center there, so it's a bit closer to my head. See how that works. Okay. Right. Yeah, there we go. And now to make my right ear, that's super easy. I'll just duplicate the left ear. I'll make sure I rename it. It's not too good to say. Right ear. And I can go into the costume, select the whole thing, and then I'll flip horizontal. Bonk. So now I've made a right ear out of it. I'll just need to move it so it's like up there, because there's the target. And the code still should have the same code in. I'll just need to change that to be right ear. Let's just click my phone. There we go. Nice. So I've got a full set of movie filter hats there. I've only got one set of ears, so I can't change those, but I can change my glasses, click on it, change my hat. So I can definitely keep people amused next time on some calls with people there. That's pretty good, I think, for costumes. But I'm just going to give everyone a second to catch up, see what kind of costumes they're making. Unfortunately, because this is like in the Scratch Labs thing, there's no easy way of sharing it in the studio like we used to do. So, but if in the end you'd like to take some screenshots of your wonderful filters and share those on social or something, that would be great. I'm just going to save mine now just to show you to do that. So as usual, you click into the Scratch project name, and I'm going to call it face sensing stuff. If I want to save that to my computer, I just click on File and do Save to your computer, and it will come up and say, tell you projects created in the labs can be saved and loaded again. They will not load in any other versions of Scratch. So you couldn't go onto the normal Scratch website and upload this stuff and expect it to work. So I've saved that now, and you can see that maybe you can see on the bottom of my screen, it's just downloaded that. So I can keep that, and if I want to come back to the website, I can upload it in there again. There's some other cool stuff we can do with it. We can try and make, so I always like making games in Scratch. I think Scratch is great for games. So I was thinking about having the one bit of the face we haven't used really is the mouth. So we could try and make a game with the mouth. And I'm also quite hungry, so I thought I could make an eating game. So I'm going to go in here and try and find some food, try and find something to eat. And there's a food category, isn't there? What have we got? We've got bananas, apple. Oh, no, it's got to be a donut. I could really do a donut right now. So I'm going to add in the donut. There we go. I'm also going to delete my rubbish green face because it's getting in the way a bit. There we go. I've got a donut. Now I'm hungry and I like my donuts, but that's quite big. So I think I need to make that a bit smaller. Let's do it by editing the costume. So let's shrink the donut down a little bit in size. Oh, still quite big. That might be a bit sick. There, that's a reasonable donut size. And I'll put that, make sure it's centered on its center. Now, what should we do? Now, let's see. So what I thought we could have is the donut could like fly around, and then I've got to catch it and try and eat it, possibly wearing all my filters as well. So let's have a look at what code we could use for that. And actually, if I'm going to eat the donut, maybe I don't want to eat it in one go. I want to be able to take bites out of it. So let's again do some more costume editing here. So I'm going to duplicate the first bit, and then I'm just going to get the eraser, get the rubber, and like rub out a bit so it looks like I've taken a bite out of it. Yeah, that could be my first bite. There we go. And then I'll duplicate that one again, and I'll erase a bit more of it. Great, and I'll keep going down until I've got rid of all my donut. So that'll be 1, 2. There's another big bite there. This is a big one. Chomp, and I'll duplicate one more. Just a tiny little bit of donut left there. So that looks like I'm sort of eating the donut. What it would do when I'm going to code it up. I'm just going to pause for a second, let everyone catch up. If you've got any problems, like I say, do shout out in the chat. So first thing we're going to do with this, obviously, is make use of that block. So if you can see here, you've got a touching thing in here. When this sprite is touched by a nose, I'm going to make that into a mouth. I'm just going to go to the costumes and first of all select the full donut. There we go. And so when this sprite touches a mouth, what are we going to do? Well, I talked about sounds, and I think actually by default there's a chomp sound already in here. Let's see. I don't know if you could hear that, but it definitely made a chomping noise on my computer. So when I touch the donut with my mouth, I want to make the chomp sound. So I'll stop the sound chomp. No, I will do play sound when done, because that gives us a bit of a pause. And then because I want the donut to look like it's being eaten, I can just go to the next costume, right? Because as you go down the costumes, the donut gets smaller. So just by doing next costume, that should let me do a simple thing. Let's just see if that works now. So if I maybe let's just add in some starting conditions. That's always good for programming. So let's have when a green flag is clicked, we'll change the costume, switch the costume to the first one, which I think is just going to be called donut, right? So whenever I click the green flag, we should get the full donut affected. So I click green flag, and then I can eat that donut. Oh, look. Amazing. It's a self-refilling donut as well. That was a bit easy though, right? Because it just stayed there. I didn't have to do anything other than open and close my mouth. And in fact, actually, you don't have to even open and close your mouth. I did it naturally, but just touching the mouth should work. Look, I go and give it a kiss. It's gone. No opening and closing is required, but it's more fun to do that, I think. But let's have the donut be hard to catch. The donut doesn't want to get eaten, so let's make it move around a bit to make this game a bit more challenging. Otherwise, it's just a how much donut can you eat game. So we'll do, maybe we could start off the donut moving by clicking on it. So we'll have a when this sprite is clicked. Move this down there. When this sprite is clicked, we'll go to a random position. So under motion, we've got glide 1 second to a random position. I think that'll be too fast. It'll certainly be too fast for me to move. So I'm going to make that make it 3 seconds. And then we want that to happen all the time, right? We don't want it just to move once. So we'll get a forever block. Drag that in. And let's see if I click green flag, which is back there. And if I click on the donut, start moving around now. Yeah, all right, actually that's a bit slow. Even I can catch that donut. Let's make that 2. Let's tweak that. There we go. I click on a donut. There we go. And I can chase it a bit. Nice. There we go. That works. The donut's still flying around there. Wait, maybe I was going to wait for it to come to me. One last bit left. Got it. Great. That's fun. I like that. it probably looks really stupid, but it was quite fun. I can imagine anyone watching like the screen without the stuff on will wonder what I was doing. That's really funny. Let's turn it into a bit more of a game though. For a game, we need to have a score first of all, don't we? Always. So let's go to variables. We'll make a variable called, I'm going to call it amazingly score. And then we'll do some usual stuff. When the green flag's clicked, I'm feeling quite full now after eating all those virtual donuts. Where we'll set the score to 0 to start off with. And also then whenever I, maybe you don't want to get a point just for munching the donut, taking a bite out of the donut. You maybe want to get a point when the donut has completely been eaten, right? So we could add in a bit more code here to say we'll only give you a point when the donut has completely gone. So we could have in our forever loop. I'm just making this up now. Let's say if what should we say? Yeah, if no, where do we need to put it? We need to put it in here, really, don't we? So replace sound. So I'm going to say if, and we can look up, we can find what the costume number is. So I think how many donut costumes are there? So the last donut is 5. So basically, if I've eaten donut costume 5, I should get a point. So I can say if costume number, there it is, I'll put that there, and I'll need a test condition. So I can say if costume number, well, let's say if costume number is less than 5, then we just go to the next costume. Otherwise, so if it is 5 and I've eaten it, then I get a point. So we'll say we'll change score by 1. And I guess we still want to go to the next costume, don't we? Because we want this to be a continuous game. See how many you can eat. All right, I've got my score up the top there. Let's see if that works. Where's the donut? There. All right, so if I eat it now, I've got to stand up. And again, it's good exercise. This chasing donuts. Come on, donut. Come on, donut. Let's go. Got it. Again, I got a point when I finish the donut, and then it can go around again. That would be infinite donut eating, though, wouldn't it? If it never stops. So we probably want to have a bit of a timer on there. So like, how many donuts can you eat in a certain period of time? So let's have make another variable, and I'm going to again be really imaginative and call it timer. You could of course call it anything you liked. Have the timer up in the top corner there, and then we can say we'll also how long did that take me to eat those donuts? Maybe about 20 seconds. So let's set. So this is under my when green flag clicked. I'm going to set my timer to be. Let's give myself 30 seconds, and then I'll need another kind of forever loop. And we could have that. We could just stick that straight after the green flag clicked. After we set up all our variables, we'll wait until. No, we won't. We'll do repeat until the timer. Repeat until the timer equals 0. Repeat until the timer equals 0. What will we repeat until the timer is equal 0? Well, we need to make the timer go down. So we'll continually change the timer by 1. So we'll change timer, not by a +1, because that would make the timer go up. We'll do -1. We'll take 1 off the timer. And then we need to wait a second, so that otherwise it will just count straight down immediately. So we'll add in a wait 1 second. There we go. So I've got my time at the top, and then well, then we could have everything stop, couldn't we, at the end there? We could have stop all, and maybe the donut will say game over. Let's get you in playing, see if that's going to work. I'm getting quite full of it. I'll click on the donut to go. Time has already gone, yeah. One more to go. Okay, gonna do it. Look, denied. I nearly had one last piece get, and I could have got 2 points there. That was so annoying. Right, there you go. Great. So we got a nice little a fun game there for using the face sensing and some of the other stuff in there. I'm quite tired actually after all that jerking around trying to get the donuts ready. I'm going to give a little pause for a second while I get my breath back, and then we can see what other people are up to. Say if you've got anything in the chat that you want to share, or anything else you've done, maybe tell me what other food you picked other than a donut. That would be good. And then we'll move on and do one more last thing, I think, in the last of 20 minutes or so. My filter's still working, right? I'm going to click green flag. Yeah, almost forgotten they're there now. One other nice thing we could do actually is to maybe we could add in like a button to make the filter turn on and off rather than having it all in there. How would we do that? We could create a button and have the button send a broadcast message to everything to tell them to appear or disappear, or we could have a button to turn the disguise on and off with a variable. Yeah, let's try and do that. Okay, so I'm going to find a button. Green button, that's very good. I'm going to put that down the bottom there. I'm going to make it a bit smaller, make it 50. Okay. And then in the code for the button, I'm going to say when the sprite is clicked. And I'm going to set another variable. So I'm going to create another variable here, which I'm going to call disguise mode. You don't have to call it that, you can call it whatever you want. Disguise mode. I don't want that shown on the screen, I don't think, so I'll make that disappear. But when the sprite's clicked, I'm going to say something like if, well, let's say if disguise mode is already on, then I'll turn it off. And if it's off, I want to turn it on. So I'll say if disguise mode equals, so if disguise mode equals, we could just have, I'm going to use 0 and 1 rather than on and off because they always worry about mistyping them. So if disguise mode is 0, which will be off, then we want to turn disguise mode on. And so if it wasn't 0, then it must have been 1. Then we're going to set disguise mode to 0, if that makes sense. So we're going to check to see, are we on disguise mode? If we're not, we turn it on. And if we were, then we turn it off. And then we can go into all of our little costume things here and get them to only appear when if disguise mode is on. So we could have inside our forever loop, we can have another if else block. So say if, let me do that same test, if disguise mode is on, which is 1, remember, if disguise mode is on, we'll do all this stuff. but also we'll if disguise mode is on, we'll show ourselves and do all this stuff, and if it's off, we'll just hide. I think that might work. Let's try it out. I'm going to click green flag. So and there you go. At the moment, disguise mode is off, so my glasses aren't there. When I click the button, they appear, and I click them, they disappear again. That's cool. My button needs to tell me whether disguise mode is on or off, though. So let's go back to the button code, and there is 2 costumes for the button, isn't there? No, there isn't. Okay, so I'll duplicate that. Then I want to do some coloring in here. So let's do a fill, and I probably want to do like a, for the center's got that gradient fill, isn't it? So I'm going to pick like the red color, have that, and do that there. Yeah, and then same thing for the outside. I just need to check the other gradient, which is that one. So it makes that kind of stripy effect around the outside there. There you go. Great. Okay. So I'm going to call that ice button 2. That'll be okay. That's the code. So let's have pink will be disguise mode on. So when we set the disguise mode on, I'll switch the costume to button 2. Otherwise, we'll switch it to button 1. That way I'll be able to see whether my costume mode's on or off. Start green flag. I click that. There we go. On, off. And then I just need to add in all the same block of code, do the same thing for all the others. Now, I could add it in manually. Let's just go and do that. So I need to have my if then else block. What I can definitely do there is if disguise mode equals 1, this is exactly the same as we did for the sunglasses. If disguise mode is on, we show ourselves. If it's not, we hide ourselves. So now when I click the head things appeared. 1, yeah, great. And I could do the same for ears, but I think I'm just going to leave the ears on for the moment. You get the idea. You get the idea. Sorry. Anyway, right. One last thing to try though. Actually, no, I do want to make my ears disappear. So let's just do that quickly. I just thought of the last little thing to try before we run out of time. Plonk that in there. You probably all remember it by now. It's if disguise mode equals 1. Disguise mode equals 1. Show ourselves. Otherwise, hide. What I'm going to then do, I can copy that onto the other ear. So that should now have 2 in there. I can delete that one, and I just need to remember to change that back to right ear. And now if I click the green flag, yeah, I can turn all my costumes on at the click of a button. Bonk, bonk, bonk. So the last thing I want to do, this is a bit of a silly thing, is to, oh, I didn't mean to click on my donut. Stop him for the moment. Of course, every time I move him out of the way, right, he's going to do that. Right, let's add in one more sprite for this last little trick. And I'm going to, I want an animal that flies. The bat flies, doesn't he? So let's find the bat. Yeah, great. In the bat, there is, oh, he's quite big. Again, I need to shrink him down quite a lot, actually. Maybe 20, that's maybe a bit too much. Let's try 30. 40. No, that first time. There we go. So what I want him to do basically is to fly into my head, look like he's going in one ear, and then fly out the other ear. So how could we do that? Well, let's see. We know that we can sense the different ear positions. So to start off with, let's have, when the green flag's clicked, we'll maybe have him just so we can find him again. We'll have him go to the center position. If I click, go to 0, 0. So it'll always be in the center. And let's say he shows himself as well, because we probably want him to hide at some point. Just by doing that, I can always click on the green flag and get him in the center of the screen to know where he is. Then when I click on him, when this sprite's clicked, I can go to a random position. Go to random position, there we go. And but I want to be on this side of the screen, or depending on which side of the screen I'm on Scratch, I want to be on this side of the screen. So I'll once I've gone to a random position, I'll go to a particular X value. Particular X value, which is far side of the screen. So the height will be a random value now, and then I'll go to about to 0 there. So if I click the green flag and click on him, not X to 0, I mean, I want him to go to the left-hand side of the screen. So that's like -220, isn't it? Right, I don't know. Look at that. Yeah, there you go, up there. So every time I click him, he'll go to a different position, different height, but he's always on the left-hand side of the screen. And then I want him to move to the other side of the screen, the right-hand side of the screen. So again, we'll use that glide function, and we'll say we'll glide this time to X +220, which is the far side of the screen, and we'll keep our Y position exactly the same. He'll just travel in a straight line, so I don't need to specify it there because I don't know what it's going to be because it's a random position, but I can just use the variable for Y position in there. So it will always keep traveling in a straight line. And let's see if that works. Yeah, there you go. That's quite good. I think that's a bit fast. Let's just slow that down again. Right, so we've got him moving, and now we want him basically I want to see if I can line him up with my ears. So the goal of the game for me will be, can I get my head in the right position so that when he travels left, he travels to the ear and disappears. So if we go to our sensing blocks, we can say when this sprite touches my left ear, then we want it to hide. And I think what I thought you could do, I was just thinking about this, is when it then touches my right ear, it shows itself again. But the way touching works in Scratch is that if a sprite's hidden, it can't touch or interact with anything. So I'm just going to have to put in something like wait 1 second. Wait 1 second, and then it will show itself again. And hopefully that will look then like it flies in one ear and out the other. So let's. That was too low then. Right, let's just test it first of all. So actually what I'm going to do, in order to test it, I'm going to remove the random position. I'll put him up here and then click on him there. Oh, I've got to get my head down low. Right, my head's too low. Let's try again. Right there. So obviously not touching my left ear. Oh wait, is my left ear on here the right one? There you go. Right, so 1 second's too long because he appeared back over here. Didn't quite line up. Where does it think my ear is? There. Yeah, okay, so maybe that needs to be about half the time, 0.5 seconds. Let's try that. My head down low again. There, nice. Look. In one ear, right out the other. Great. So now we can put the random position, and then you've got to move your head quickly to get it to do it. And again, you could have we could add in a score, couldn't we? So that when you successfully line your ear up with the flying creature, you get a point. Let's just see if the random thing works there. Great. Turned up right height. Where's it going to go next? Click next. Down, low. No, missed it. Up again. Oh, much too high. I'm not standing up to get that. But there we go. That's another fun thing you can do using. I think we've now looked at all of the different blocks you can get on there. The other thing you can do in here, which we didn't really look at, is to see when a face is detected. So you could have you know, a blank, nothing on your camera, and then say set an alarm so that if someone's in front of your computer, something happens. So maybe you could leave your screen on a scratch window, and when a face is detected, it could pop up a message and say, like, "Oi, stay away from my computer," something like that. The other thing I also wanted to try out was to see whether or not a drawn face would work. So obviously, what I did was I drew a face. Yeah, it's not a very good face. But if I move myself off, if I turn the filter on, green flag first, turn filter on, and if I move my head off screen, and then put this drawn face in, is it going to detect it? Maybe I need to press the green flag again. No. So it knows my rubbish drawing of a face. Oh, it sort of picked it up there. Look, maybe that was just movement, kind of. Now you see, it's clever enough to know the difference between my face, a real human face, and a drawn face there. Maybe that's, again, it could have done with Aussie to do a much better face than that. But it knows which one is me. I think I've covered just about everything I wanted to cover today with the face sensing blocks. I hope you've had fun with that. I've seen there's one question in the chat, which is, how do I make the ballerina bigger? So I'm guessing you've added in a ballerina sprite in here. Is that right? Let's just see. So is there a ballerina? There is ballerina, right? Great. So if I add the ballerina in, if I want to make it bigger, I can go in here on the size and change that. So that if I make that 200, make it twice as big. The other thing I can do is I can go into the costume of the ballerina, select the whole thing. Click the arrow, select the whole thing, and then I can drag it here to make it smaller or bigger. That's how you resize any sprite. Hopefully that answers your question, Kingston Music School YouTube. Thanks for watching. Right, we've got 3 minutes left, so I'm just going to see if there's any more questions. And if not, we'll get ready to move on to the next presentation this afternoon, which is all about Python. And it looks really good, so I'm going to stick around and join in with that Python session. If there's any more questions about the face sensing, please chuck those into the chat now, and I'll try and answer them quickly. I'd love to see any of the cool projects that you can make with it. Your own choice of filters, maybe any games you can come up with that get you a bit active. It'd be great to see those getting posted on Twitter or social media or something like that, or just email them in so we can maybe share them on the next stream. I've lost my work, so I'm having to make it again. Oh no, never mind. It does happen. That's a good point, though. I'm going to not do the same thing. I'm going to make sure I save this to my computer right now. So I've clicked on save, and that should download it, so I can play these games again. And hopefully we'll see the face detection stuff appearing in the proper version of Scratch very soon. I think it works pretty well. If you notice when you first go to the page, there's a give feedback thing. I left some feedback saying I thought it was really good. Hopefully other people will have done the same. Okay, so we're coming up to 10:02, and we're going to start the next session. I'm just going to hand back over to Peter, who's going to introduce that. I'll just stop sharing my screen as well.
Richard, absolutely amazing. I loved it. I can't wait to have a go, and I can't wait to see the projects that the youngsters post in our studio, because I think it's really wild.
It's a lot of fun, right? It's a lot of fun.
System, isn't it? Oh, it's just amazing.
It's great. I think
okay,
it's really
that's so cool. So now we're going to move on to Jonathan, if he's waiting in the wings, to join us for the session on the Tour de France, a cycle race simulation. Jonathan, it's very exciting. I love cycling. I think you probably do as well.
Yes, indeed. Yeah.
So I can't wait to see how this works. Over to you.
Cool. Hi, everyone. Hope everyone enjoyed the lovely weather today. So today we're going to talk about cycling and we will talk about how we can use Python for cycling simulations. So let me just set it up to, I'll just share my screen first. So if I share my screen, so yeah, now hopefully you will see a tab, so saying cycling simulations. Yeah, here you go. So I think the first part of today we'll talk about we'll first talk about some like physics on how cycling works in real life. We will play around with these tools, which you can have a look. So I think if Richard can stick this link on the chat, that would be really helpful. So yeah, everyone can play around with that link. Maybe I stick it on the Twitch chat as well. So yeah, the first part of that, we will play around with these tools. We will do some experiment. We may talk about like how we can do experiment properly as you learn in school. And then the second part, we will look into how we can use Python to interact with the cycling model more effectively because clicking around, it may take ages or hours to do experiment, but using Python is more efficient and is quicker and easier that way. Okay, cool. So let's jump into this. So maybe we can first think about what is simulations. So if you are around last time as well, we look at another example of simulations, but this time is a slightly different. So it is basically doing an experiment on a computer. So everything is virtual, so you can play with the model, play with that on the computer. You can come up with scenario doing a different kind of experiment. And because it's in a computer, so the computer will do all the hard work for you. So you don't need to work out all the painful equations on a piece of paper. So that's quite handy. And cool. I think let me just I attempt to talk about what is a Tour de France time trial. So I'm not sure if there's any cyclists in the chat, or if anyone try cycling up a hill. So sometimes it's very difficult to just pedaling up the very steep hill. And in Tour de France, they actually needed to do that for 3 weeks in a row. So that's quite intense for a cyclist. So if you think about a bike, so what actually moving the bike forward? So all the power, all the forces are from the rider, which is a human being in this case. So the harder the cyclist ride, more force will apply to the bike, and therefore you can pull yourself up the hill. But what is stopping the bike from going forward? So you can think about it could be air resistant, like faster you go, you may feel the wind a little bit more. So that's air resistant. It's actually related to your area as well. So bigger you are, more air resistant you need to overcome. And weight is also very important. So weight of either the cyclist or the bike will have a very big impact, especially going uphill. So you can see the diagram here. So that's basically all the basics forces applied to the bike. So yeah, pedaling force is from the rider. So harder you pedal, faster you could go. And the air resistance is stopping you, and the weight of the cyclist and the bike will also stop you. Okay, so let's jump into this so we can do some experiment using this tool. Cool. So this tool will show you a stage from Tour de France time trial last year. So you can see is yeah, somewhere in France. If I zoom out, is somewhere in France. Let me just prove to you. So yeah, it's right next to the France and Switzerland border. It's very hilly area. And cool. So and you can see the elevation profile here as well. So for the first bit is pretty flat, and for the last bit it's going uphill a lot. So it's from about 500 meters. So you can see the y-axis is in meters. So it's from about 500 meters all the way to nearly 1,000 meters. So it's pretty intense. Cool. So this is the track we are going to use to do this experiment. So cool. So this two, you can put in different numbers on the like some datas on both the rider and the bike. There are a lot more informations if you want to see, but yeah. But let's just do an experiment. Okay, let me just quickly reload this. Yeah, just bear with me 1 second. I think my computer is just struggling a little bit. Yeah, I mean, if you have the link as well, you can play with it. You don't need to look at my screen. So yeah, when you click on, let's see how fast you can go, you will, yeah, the computer will generate a result for you. And you can see the lap time, the total time it takes to finish the whole Tour de France stage. Okay, let me just refresh another time and maybe minimize it. I just want to make sure my computer is in good state. Cool, I think it's working. So it's doing the calculations in the background. So as you can see here, so this is the second graph is the velocity, the speed of how fast I could go. So as you can see, right here is going downhill a little bit. So that's why you're going a lot quicker. And for the last bit is going uphill. So that's why the velocity, the speed is a lot slower than for the first part. And if you think about how you do experiment in school, so you always need a control experiment. So say if you want to look at, like, for example, photosynthesis, you need an experiment with oxygens and need another control experiment without oxygens to do a back-to-back comparison. So this is a good practice we should follow. So for doing this kind of simulation experiment, we need to follow this approach as well. So yeah, maybe this time we can just change one variable to do a experiment and then comparing back to back. So before that, it was 64 kilograms. So maybe we can look into how about if we increase the weight? So if we increase it to 80, we can give a name for this experiment. So higher weight, and then we can generate an experiment. So in a few seconds, it will basically do another run. So we can see the baseline, which is the one we did with 64 kilograms, and then the higher weight is the one we just did. So so yeah, basically we're comparing a 64 kilogram cyclist and 80 kilogram cyclist and see what's the difference. So as you can see, the total time are quite different. So one is 1 hour 3 minutes, and the heavier cyclist is 1 hour 9 minutes. So there are 6 minutes difference, and you can see the speed are quite a little bit different as well. It's not huge, but it's obvious enough. It will make a 6-minute difference. So I think following this kind of approach is a very good practice. So when you do an experiment, you make sure you just change one variable, otherwise you're comparing apple to orange. So make sure what you do is it makes sense in your head. Cool. So you may think about how can you, if you want to compare, like look at the interactions between weights, power, different things, how can you do many more experiments? So in theory, you can like just click around on this website again and again, generate many experiments using this website. But it's not very efficient, is it? Because you have to click around many times. So in this case, you can actually do it in Python. So this website is written in Python, so everything is under the hood is in Python. So if you click on the first link, hopefully you will see a page like this. So yeah, let me know if you can get to that link. So if you're on this page as well, you can also click on Advanced, Explore with Python, and then it will go to Binder. It will generate a Jupyter notebook for you. So yeah, maybe on the chat, you can give me a thumbs up when you can see the Jupyter notebook. I can give you a few seconds as well to catch up with playing with the website. So yeah, hopefully you will see a Jupyter notebook when you click on that. So yeah, it's yes, stay on that Jupyter notebook if you're there. So yeah, click on this if you couldn't see the link. Cool. Give me a yes if you can see the notebook. Cool. So yeah, let's crack on. Not sure if you used a Jupyter notebook in the past, but yeah, I will show you how to use that as well. Cool. So if you go to the first cell to execute a Jupyter notebook, you just need to press Control Enter on that cell. So a cell is this box. So if you click Control Enter, it will basically run all the lines in that cell. So it's basically do a print and then load the image from a website. Cool. So yeah, before we do more simulations using Python, so let's think about this cycling problem again. So what stopping us going forward is air resistant and is the weight of the cyclist and the bike. But how do we know which one is have more impact on it? Is it the air resistant or is it the weight? Should I minimize the weight or should I minimize the air resistant? Which one is more important? So yeah, we don't know, right? So we can look at the math or we can try to understand a bit more, but we can also do experiment using Python. So yeah, let's just keep this idea in mind and we will visit this again. Cool. So the second part of this, we're going to focus on Python. Some of the concept may be quite challenging. So yeah, just let me know if you struggle, and then yeah, type of questions on the chat. I will keep an eye on the Twitch as well. Cool. So to do all the experiment, we need to import some library and classes first. So those are all the classes we need. So there's a bike, which define some of the physics or some of the numbers data in the bike, and environment, rider, stage are all the same. So it define the data for the rider, for the bike, for the environment, and for the stage as well, like elevation, etc. And the last one, simulations, is the most is quite crucial. So we will look into that later on. So this class will give you the results at the end of the run. So yeah, so just bear in mind we need to interact with that class later on. So some of the class may be a bit difficult to understand, but I will walk you through. So yeah, let's Control Enter this cell as well so that we import all the library. Cool. Okay, so I'm not sure if you came across this command. So if you do simulations and then 2 question marks, if you do a Control Enter, the Jupyter Notebook will bring up another window at the bottom. So what it does is it will show you the scripts, the Python scripts for that class. Cool. So if we just quickly look at this, so simulation is a class, and there are a few attribute in the class. So like, so your say simulation not found. I think I think you need to run this cell first. So on all the imports, make sure you do Control Enter. Yeah. So right now it say 38. If it doesn't give you a number, it means it hasn't executed that cell yet. So yeah, make sure you import all the library. Cool. So yeah, so we're looking at simulation class. So there are a few attributes, and there is two method. It is very complicated and confusing, but we don't need to focus on those for now. So if you when you have a new class, you always pay attention to the arguments and what it gives you. So it takes in a few arguments like power, as we're not sure what is it yet, but we will look into it later. And then there's a second one as well. So solve velocity and time, and I think that's what we need. The name suggested this could be very useful. So it solved the velocity and how much time it requires. So this is very useful to us. Okay, so let me just close this for now. So a double question mark will give you everything on that script, and a single question mark will only give you the documentation bit, which is human readable. So this is quite useful as well. Cool. So yeah, double question mark and a single question mark. Okay, let's do some experiment. Cool. So I think those are quite obvious. So you define some data for the rider. So we can see 50 kilograms and the bike is 6 kilograms. There are some value as well. So now we need to set it up so that we can do experiment. So we need to initialize a class below. So maybe let's bring it up again so we can see what's going on. Okay, so we need to initialize a class. And if you look at those attributes, so those, we need to define those before we can do anything. So yeah, let's just copy and paste those. So for rider, we need to assign this rider to be an argument passing into the class. So if you pass this rider to the class, that's how you would do it. And for stage, we need to pass stage into stage. And for nth environment, we need to pass nth to the class. And for bike 1, we need to pass bike. Cool. I'll let you finish all the typing. I'll give you a few seconds to catch up. When you finish typing, you can execute a cell, so you can do a Control Enter. Okay, so let's carry on. So yeah, so now we initialize the class. When you're done, you can actually execute one of the functions, one of the method in the class. So so we don't need to do anything here. So those are just some more data we need to define, and those are the data, and this is the power from the rider. So we are saying that the rider will give 150 watts constantly all the way. So 150, that's where you define the power. And now we need to do some typing again. We need to call the method from the class. So yeah, we need to pass some arguments to the method. So how can we do this? So we need to actually pick up this. So this is the class we just initialized, and under the hood there should be a method called soft velocity and time. So this functions, the name suggested, it will give me the time and velocity. That's what I want. That's great. And if you look at those, we need to define S power V0 and T0. So let's just copy and paste here. So for S, we need to define passing stage to S. So S equal S. And for power, so this power, I need to pass into this power. Okay, sure. Let me just finish this line, and then I will give you a few seconds to catch up. So this is the line we just did in the past, in the last cell. So we define simulation. And for the next cell, we define the functions in that class, soft velocity and time. Yeah, give me a let me know on the chat when you are done, and then I can move on. Would that be useful if I copy this line to the chat so that you can follow? Okay, maybe I can paste that in just to make sure. So this is the last line you need to do. Yep. So yeah, so the one I just pasted is the line you need to initialize the class. And for the second lines, you need to initialize the method. That's on the next cell. Okay. Yeah, let me know if you need help. I will keep an eye on the chat as well. Okay, so when you're done with typing, make sure you execute a cell. So you run the cell by Control Enter. So right now you can see there's a star right next to the cell. It means the computer is doing some math, it's calculating in the background. So after a few seconds, it will print out the answer for you, which is time is 2,200 something seconds, and it will give you the velocity as well. Let me know when you can get to that stage, and then we can carry on. If you set everything up correctly, you should be able to run the simulations. So yeah, if you control enter this cell, you should be able to see time and average velocity. Yeah, let me know if yours doesn't work, and we can have a look as well. Okay, so we have done the first calculations. So this is like the control setup, control experiment. We need to set up. We need to know what is the baseline. But yeah, when you look at the data, like look at the time, look at the velocity, sometimes it's not very clear what does it actually mean. So you can actually visualize those data if that's help in any way. So we're using a library called matplotlib. It is very useful for some visualizations. So we can plot the data and see what it does. So we don't need to type anything on this cell. We just execute it by control enter. So it will give you two graphs. So the first graph is velocity versus time, and the second one is elevations versus time. So yeah, so you can see because of the elevations is increasing here, we will see the velocity is dropping, and when the elevation is decreasing because it's going downhill, you are speeding up as well. This is quite good. You don't need to pedal as hard. So yeah, it's gradually going uphill here, and then it's more or less a lot lower than before. So yeah, so you will see there's a trend between the elevations, so going up and down to your velocity. So you can just think about like what makes you go faster. It could be the gravity. Cool. So so now we are on the next sessions. We can actually do an experiment to find out what's contributing to the speed of the bike. Yeah, let me know on the chat if you are struggling. I can always revisit. Yeah, cool. So yeah, now let's do a experiment. So we have so yeah, we've got the baseline. So let's do experiment with a little bit lighter bike. So it's basically those instructions. So if we decrease the bike weight by 10%, so yeah, at the moment the bike mass is 6 kilograms. So if we decrease that by 10%, so let's do 0.9, so it should be 5.4, right? So if we decrease the weight by 10%, do you think the time it takes would decrease 10% as well? This is a very good question, so I'm not sure. So let's do experiment. So we need to set up, okay, so yours say does not do anything when I press Control Enter. Which one is it? Okay, so let's just look at, I think if you do Control Enter on this cell, it doesn't do anything. Is that right? So if you do Control Enter on this cell, it won't does anything. But on the next cell, when you actually look at the speed and velocity, it will give you a time and average velocity. So this one, when you do Control Enter, it will give you an answer in a bit. And on this cell, you type this line as well. So simulations, solve velocity and time. Okay, so I've just copy and paste the line you need on the previous on the chat, so you can have a look at that as well. Let me just copy and paste again. So you need this line. So you need that line just after pass argument to method, and then you should be able to run the cell. Cool. If you have that, can you do Control Enter on this cell? So you can do Control Enter. It will be a star for a few seconds, and then later on, it will give you the answer. So yeah, when you paste that line on this cell, you should be able to run it. So what it does is, does it have any error message? Like, I think another thing is you need to make sure you have import all the libraries. So make sure there is a numbers right next to all the libraries. So you do a Control Enter, there should be a number next to all those library. And then you need to make sure you have run this cell as well. So do a Control Enter, it will give you a number. And the last thing we did is we define solve velocity and time here. And then when you run this cell, it will give you time and velocity. Okay, I think if you struggle to follow, I think you can have a look at the example as well. I can paste you a link on that. Everything is on GitHub, so you should be able to have a look and experiment on your own. Cool. I think we've done visualizations. So I'm trying to show you when you do a experiment. So yeah, if you struggle to follow, I think it's okay to just look at what I do to get a feel of how to do experiment, and then you will see very interesting result later on as well. So yeah, just bear with me. Okay, so now we have the baseline. We want to do an experiment. I can paste you the GitHub link later on, but yeah, just watch in the meantime. Okay, so the bike mass, we want to make it 5.4 kilograms, so it's 10% lighter. Cool. So 10th bike mass is 5.5, and for simulations, we basically need to do what we just did. Let me just copy and paste, grab the line. So we need to define all these, pass in all the arguments to the class. So simulations is, so we have rider, we have stage, we have environment, we have bike. So make sure you execute the cell. So yeah, give me a number, so that's a good thing. And then we can run the simulations. Let's double check. Everything is there. Okay, cool. So what we're doing here is we just change one thing. So we decrease from 6 kilogram to 5.4. Okay, so that's the time. And it said it is 0.8% quicker. Okay, this is very interesting. So we make the bike 10% lighter, but to do that, we only gain 0.8% quicker than the baseline. So this is not very, it doesn't correlate, right? Like you expect if I decrease something by 10%, I may have increased by 10% quicker. But the model seems to suggest this is not the case. So yeah, this is interesting. So maybe instead of weights, we can look at different things. Remember in the diagram in the beginning, we talk about like weight and power and drag. So maybe we can investigate the effect of power on the time. So before that, we were using 150 watts. So maybe we can do 165 volts. So it's a 10% more power. So if you increase that by 10%, do you think your time is going to be 10% less? I'm not sure. So let's have a look. So make sure you execute the cell. Make sure you have set everything up correctly. So this line is very important. This line gives you the answer you care about, basically. Okay, so let's run the cell. Okay, so the computer is thinking in the background. So now it's done it. Cool. So it says is 8% quicker. So what we did here, we increased the power by 10%, but by doing so, we only make it 8% quicker. So it is like not, it doesn't correlate very well with our thinking, right? So maybe this model is actually give you some useful information. Okay, so we mentioned in the beginning of these sessions, we can use Python to do many more experiments. We don't need to click around on the website, right? So just now we just did 2 experiments. So what about if I want to do 5 or 10 experiments? Do I need to like go to the cell, change number, and do it again? No, we don't need to do that. We can use a loop to do that. Okay, so maybe if you can go to that cell, you can join in if you could. So right now I want to set up a list of power from 1,000 to 400. So say for example, you can do 100, 200, 300, 400. So it's a list from 100 to 400. Okay, so let's print that, make sure it's correct. Cool. So let me set you a challenge. So what if I want to range from 100 to 400? So it starts from 100, finish at 400. But I want to have an incremental of 25. So what it means is, so the first one is 100, and the second one is 125, and the third number is 150, etc., etc. So how can I do that in Python? So I can easily type all the number, like 200 and then 225, but this is not very clever. So is there a way that we can programmatically generate all the number for us? Any ideas on the chat? So what we need is, I want the first number to be 100, the last number to be 400, and I want to have a 25 incremental. How can I do that? Okay, so not sure if you heard of list comprehension. So we can type all the number in a list, but we can also use list comprehension. So a list comprehension is in the form of this. So it's something like this. So what I will become depends on what goes after in this bit. So because we're asking for starting from 100 and we want to finish at 400 and we want a size incremental of 25, so we can do it this way. So this is called list comprehension. It is very powerful. We don't need to type all the numbers ourselves. And let me just execute this out, make sure it is correct. Okay, so it's for I in range. I'm missing an in. Okay, cool. So it's working. But we are asking for 100 to 400, right? But we are missing 400 at the end. So we actually need to be a bit fix this. So yeah, now it's correct. So 100 to 400. So yeah, we generate a list with all the power we're interested. So now we can ask the model generate some numbers for us. Okay, so if I execute this out, it will take some time to do that because it's calculating a lot of math in the background. So you can see there's a star, which means it's running, but yeah, it just takes its time doing. So we have the first number, which is from the first element. So yeah, now we just need to wait for a bit. Yeah, wait for it to catch up. So yeah, with the second number, that's great. Okay, so what we're doing here, we try to look at a range of power to see the effect of power and time. And then later on, we can do a plot, see if there's like linear increase or linear decrease or exponentially increase. We may heard of the word exponential a lot over the past, I don't know, 12 months, 18 months. So yeah, we may see some kind of exponential graph later on. Okay, so now we have a lot of numbers, but because of the star, it means it's still calculating in the background. So let's just wait for a bit. And then later on, I'm going to do the same technique using that list comprehension to iterate a range of mask, a bike mask. So you will see the effects of mask on your time. Okay, so now it's done. So let me just set this up. So we can use the same technique. So for what is that? I forgot. So for I in range, and I want it to be between 5 and 15. So maybe we can have less experiment. So we can have maybe 2. So the first one will be 5, and then 7, 9, etc., etc. That's not what I need. I want to print this out. Okay, so 5, 7, 9, 11, 13, but we need 15 as well. So let's do this. Cool. Okay, so what we're doing here, we're iterating the mask, and it will give me the time I need. Let me cross this out as well. Okay, maybe I can ping you the link on GitHub while it's executing in the background. So yeah, if you so here, let me just, so this is a complete copy of the Jupyter notebook. So if I copy this link, and then you can play with that link later on. So you don't need to type anything on that Jupyter notebook. You just need to run it, like execute a cell, and then it will give you the answer straight away. Okay, let's come back to this, the notebook we are looking at. So we are still waiting for field results. Hopefully it will be finished soon. Cool. Okay, so it's all done. So let's visualize again, see the relationship. Okay, so what we are looking at right now, so the first graph is your power. So this axis, your x-axis is your power. So we are range from 100 to 400, and this is the time. And it's not linear, it's not a straight line. So you will see for the first bit, so from 100 to about 150, the time decreased dramatically, exponentially, as we call it, for the first bit, but then it tails off when you increase the power. So does it mean if you increase your power to infinite, say if you have 1,000 power, does it mean you will have a very low time? Looking at this graph, possibly, but as you can imagine, in real life, you can't have infinite power. It's not sustainable, and your body's will exhausted by the end. So there are some constraints we need to think about. But yeah, looking at those graphs from 100 to 400, it seems like from 300 upwards, your um, your benefit actually trade off, so it's plateaued and it's not give you a lot of advantages. And if you look at the second graph, so your x-axis is your mass. So we're starting from 5 to 15, and the relationship is actually linear. So it's actually is very interesting. So if you want to do upgrade on your bike, and if your bike is from 15 kilograms, you want to do some upgrades to 10 kilograms. So your time save is actually proportionate linearly to how much weight you save on your bike. So yeah, that's something good to know. So in theory, if your bike is infinitely light, you will have a theoretical time you can achieve that. But it could be a very expensive bike. Depends how much you want to spend. So yeah, so by doing this kind of experiment, we can quickly see the relationship between different parameters and the effects. So yeah, hopefully that's useful. So yeah, I got a few minutes left. Maybe I can just quickly show you the Jupyter notebook I just pasted on the chat. So if I bring in another window, let me double check that. So yeah, this is the complete versions of the link I just pasted. So you don't need to execute anything. So you can just control enter all the cell. Yeah. So yeah, basically you can control enter all the cell, and it will give you the answer straight away. Hopefully that's helpful. And of course you can play with the website we were looking at. The yeah, let me just bring it up again. So yeah, you can also do some experiment on your own. So get started. You can change some of the parameters like weight, and there are a lot more you can experiment with. So if you click on more, there are more variables, parameters affecting your performance on the bike. You can always click on learn more to know more about those, understand the physics of bike. Hopefully that's useful for you. I think that's about time, so I will hand back to Peter.
Wow, what can I say, Jonathan? That was just amazing. Absolutely, so much in there because cycling, all the dynamics and the amazing charts and some maths and very powerful professional tips and tricks with Python functions and constructs. There's so much to play with. So our advanced ninjas will have a field day. So thanks so much. That was brilliant. And thanks for all the help in the chat by the mentors as well, and from you, Jonathan. So now we're going to move on to something different with Aya, showing us how to build an amazing version of Breakout. Breakout was, the legend is that Steve Jobs, before going on to found Apple, when he was a young guy working for Atari, was involved in designing it. It's not clear whether that was true, and Steve Wozniak as well was reputedly involved. So it's part of computer history and archaeology. But anyway, Aya, over to you to look at Breakout and the amazing Pygames library.
Thank you, Peter, and thank you, Jonathan and Richard as well. Those have been some amazing sessions, and now we're moving to completely different. So, as Peter has told you, Breakout is one of the classic games in history. It's a very important game as far as game development goes, and we're going to be using Python and the Pygame module specifically to build our own version of Breakout. So before we get started, I'm going to pull up one that I made earlier just to show you what Breakout is in case you're not familiar. So let me just start my camera here at my screen and we'll get started with this. So hopefully you can see my screen now. And now we're going to actually run this version of that I made earlier and show you what Breakout looks like, just in case you're not familiar. So this is Breakout. We have three very key elements. We have a paddle at the bottom of the screen controlled by the mouse, a ball that will bounce around the screen, and bricks on the screen that the ball will break and bounce around as it breaks them. And the idea of the game is very simple: break all of the bricks. So this is what we're going to be building today using the Pygame library in Python. So let's get started. I'm going to take this away now. And the first thing to do is when you're on Trinket, trinket.io, is to make a new trinket. Specifically, you need to make sure you're making a Pygame trinket. If you don't make a Pygame trinket, then you won't actually have the Pygame window on the right-hand side here that you can use to play your game. So I'm going to make the font bigger, make us full screen here so you can see everything, and we're going to build Breakout. So it's worth noting that unless you have a premium account on Trinket, you can't actually save your versions of games that you make here. So it is always best when you're done to just download a copy of your code, save it on your computer, just in case you want to revisit it later. I'm just going to say that now, just in case. So the first thing we need to do is the most crucial part is actually import Pygame. So we're going to do that on line 1 here. And importing Pygame is very important because obviously that's what we need to make Pygame work. And now we're going to just kind of set up our environment a bit so that we are comfortably organized, everything is separated, our concerns are all in their own little sections, so we can keep track of our code, because it will get quite complicated towards the end. So I'm going to create a section here for variables. This will be global variables that track the settings of our game. An area for objects or sprites. Pygame is object-oriented. Every sprite has its own behavior and its own methods. And we'll look at that in a bit more detail when we start actually building some sprites. We're going to have a section here called Building the Game. This is where we will actually set the stage of our game and create the environment that the user will play in. And then we'll have a section here called Running the Game. And this is where the game will actually begin to run. So the first thing we want to do before we do anything else is just create some of the settings of our game so that when we start building the stage, we have all of this made, and it's easy to change in the future if we want to. So first of all, we're going to have game FPS. And this is just going to be a variable at 60, and this will just control how quickly the game runs. In this case, it will run at 60 frames per second, and this will all become important later, but it's good to have this variable here. Next, we're going to have game width, and we're going to have game height. And these are we're just going to use 600 by 600 for now. It's quite a comfortable size. You'll see when we actually run it, that creates quite a comfortable window to play in. And now we're going to make a background color. And the background color will be a tuple of numbers, and it will be in RGB values, so red, green, blue. If we make everything 0, we will get a black background. And similarly, if we make our foreground color here, and we make this 255, 255, 255, we will get white. These are just RGB color values. Next, we're actually going to start now setting the stage of our game. This is where we're going to create actually... oh, sure, I can go slower, no problem at all. Of course, the code will always be on screen as well if you want to copy it. But I can go slower. So here we are just, of course, setting up some variables that will be used as settings for the game. So we're not actually quite building the game just yet. Now what we're going to do is actually start to build the game. And the first and most important part here is to perform the function pygame.init. And this tells our code, okay, start running pygame, let pygame start doing its thing. And everything below here now will be actual pygame methods and functions that allow pygame to create our game. Now we're going to create a small variable called clock. And this is going to be pygame.time.clock. Make sure that C is capital because we are calling a class constructor here. And this is saying create an object called clock, and this clock object will actually be what controls how fast the game runs. So it will become important later. Next, we're going to actually make the screen. Of course, when you're playing a game, you're looking at a screen. Everything takes place in a little window or on a stage. And this screen is the stage on which our game will be played. And this is quite a complex bit of code here, but we are calling a set of pygame libraries here. We're going to call pygame.display.set_mode, open our brackets, and then we're going to open brackets again. Make sure you have double brackets here, because we have a tuple of information. And then we're going to pass in game width, game height. So what this line is saying is okay, make a new screen. This screen is going to be where our game runs. And here's where we pass in the size of the screen. And we defined these variables up here, of course. So we are making a 600 by 600 screen. Now we're actually going to make the game run. So we're going to say in our running the game section here, we're going to create a permanent while loop. And a while true loop runs forever, continuously loops until you specifically tell it to break out of that loop. And then we are just going to do screen.fill background color. This says take the screen and fill it in the background color, in this case black. Now ideally when I run this bit of code we should just get a black box on the right here, which is perfect. This means now we have this black box on the right here, and this black box is now where our game is going to start appearing. So we're going to now start building out a paddle, start building our ball, start building our bricks, and we're going to create these entities within our game that will interact with each other to create the breakout experience. And this is all done using sprites in the Pygame library. So this is where we get into a bit of object-oriented Python programming. And if you know a bit about object orienting, this will be simple to you. But essentially, when we make a main.py line 23 while true, you have probably defined your true loop incorrectly, or you haven't put anything inside it. You might need to take a look at the way this is laid out here and indented correctly. It looks like your while true loop isn't defined correctly. So just take a look at what I've got on the screen here and make sure you've got it very accurate. I will actually, before I go any further, share what I have here with you. and as a link so that you can just use this as a basis to move on from if you would like to. Okay, so now we're going to go back to the full screen here. And we're now actually going to start building our object. So when we create a class, we are creating an object, and a class will have some various features. But the best thing to remember is that when we make a class and then call that class later in the code, it creates an object in the code that exists on its own, and you can call that class multiple times to create multiple objects of that class. And that's what we're going to do. So we're going to create a new class here, and we're going to start with our ball. So all we're going to start off by doing is making a ball just bounce around the screen, and then we're going to go from there. So when we make the ball class here, make sure your B is capitalized. That's very important when making new classes. And we're going to call the superclass in here pygame.sprite.sprite, just like so. And then we're going to create what's called the class constructor. And of course, again, this is very simple, but you just do def __ init _ brackets self. And then like so. And this means whenever we create an object of the class ball, we run the bit of code inside here. And this will get very simple, but as long as you have something that looks exactly like this, whenever you create a ball, this bit of code inside def itself will run. And the first thing we need to do is instantiate the Pygame sprite. So we're going to make a sprite object, and we now need to give it all the behavior of a sprite. So we're going to call pygame.sprite.sprite. The second sprite is a capital S. That's very important. This is all case sensitive. Init self. And this bit of line says, okay, give our ball all of the behaviors of a sprite, which is very important. And this is all very boilerplate stuff. So once you've typed it up once, you can just copy and paste it later, which you'll see that we'll do, and you'll never need to worry about it again. So now we're going to actually do some things to our ball. First of all, we're going to give it an image. So we're going to call self.image. And this says, give this ball an image. And we're going to give it an image of pygame.surface, again, capital S, very important. And we're going to pass in an array of 20, 20, just like so. And this says, make our ball an image, which is just a 20 pixels by 20 pixels little box. And we'll look at that shortly. I'll actually draw up some diagrams for you to show kind of what we're doing here. But next, we need to give our ball a color. Because right now we're just making a little box. Now we need to give it a color. So we're going to call self.image.fill. And we're going to fill it with foreground color, which is, again, we defined it at the very start here. So we're saying, okay, make our ball a little 20 pixels by 20 pixels box, and then make it white. Next, we're going to call a nice little function called image.getRect. So every sprite in Pygame has what's called a rect, which is a rectangle that always surrounds the sprite. And when we move this rectangle around, that's how we move the sprite around the screen. So we will manipulate the rectangle. If you're familiar with game terms, we're essentially moving the hitbox of the sprite around. So we're going to make self.rect. And we're going to call self.image.get_rect. So we've now got a variable within our ball called rect, which is the rectangle that constantly surrounds the sprite. And now we're going to place the ball somewhere. So if ever we call self.rect.center, we're saying move the ball to this place. And just for now, we're going to put it as 300 by 550. So I'm now going to draw up a small diagram here for you, if I can find my tablet pen. And I'm going to show you what I mean when we say this here. So let me just get to our little whiteboard here. So this is our screen. And at the top left here, we will have a position of 0 by 0, x 0, y 0, which means down here in our game, the x is 600 and the y is 600. At the top right here, our x is 600 and our y is 0. And at the bottom here, our x is 0 and our y is 600. So these are positions actually on the screen. And The reason we're looking at it like this, so when I put the ball down in 300 by 550, I'm kind of putting the ball in, it'll be around sort of 300, so in the middle of the screen, and at 550 kind of towards the right here. So actually, no, it'll be 300 towards the middle here and 550 down here. So our ball will sort of appear in this kind of area here when we run the game. And that's what we want to happen. So now we're going to actually make that happen in our game. So we've got a ball. Well, we've got a class of a ball. Now we need to actually call this class to make the ball exist within our game. So this is where we're going to go down to our building the game section. And there's a few stages to doing this. First of all, we have to make a group. And we're going to call this ball group. And every single sprite we will put in to a group of sprites that match it. And the reason we do this will become very important later on, but it's a great thing to do now. So we're going to make ball group equal pygame.sprite.group. So we're saying ball group is a group of sprites. And then we're going to say ball equals ball with a capital B. So lowercase ball equals uppercase ball. And this says, okay, make a new ball object and name it ball. Very simple. We can keep track of that nice and easily. And now we're going to say ball.group.add the ball. So now we've made a group where our ball will go. We've made the ball object. And now we're going to add the ball object to the group. And it seems a bit redundant to make a group and only add one item to it. But later on, it will become very important. And it will actually become important almost immediately now as we draw the ball onto the game. So the first thing we need to do before we fill our screen with any color down here in our while loop, we need to call the method pygame.display.flip. And this says delete everything currently on the screen. And it will do this every single frame. It will delete everything on the screen, and then it will fill the screen in black. So every single frame, the screen everything will be deleted and then painted in black. Yep, I can certainly slow down for you. But so what we're doing here is we are deleting everything off the screen and then painting it in black. But we will be doing this so quickly that when we're watching the game, we won't actually see anything being deleted. And to say that we want to do this 60 times per second, we're going to call clock.tick game FPS, which are all things that we made earlier. We made the clock earlier. Now we're going to tick it for 60. And what this says, in essence, is this loop can only run 60 times per second and no more. So we'll try to make sure we maintain at 60 frames per second so the game feels smooth as we're playing it. So now we've made sure we're running at 60 frames per second. We have deleted everything off the screen, and now we've drawn the screen in black. The last thing to do is actually draw the ball onto the screen. So going to call ball_group dot draw, and then we're going to pass into our brackets here screen. So this says onto the screen, draw our ball. So ideally, when we run this now, we will have our ball just appearing on the screen. So let's try it. There we go. We can see now the first element of our game already kind of exists here. We have our ball sat here on the screen. But this is kind of boring, right? This is just kind of sat there not doing anything. So now we need to make the ball actually move around. So up in our ball object here, we're going to give our ball a new method. And this is going to be def move. And this is going to say, okay, this is a method that we're going to call whenever we want to move the ball. And we're going to need to also create two more variables here inside our definite self method. We want to create self.velocityx, and we're going to just call this 6 for now, and self.velocityy. And I'm going to explain why we're doing this now. Whenever we move the ball, we need to tell it how far to move every single frame. I can share the code as it stands right now. Yes. So let me just do that for you. Save, link, copy, and here we go. Okay, so that's the code as it stands at the moment. Okay. So now we need to, this here, self.velocity_x and self.velocity_y tells the ball, okay, move 6 pixels every single frame. So this is where we now actually begin to start moving the ball. So if we look at our lovely whiteboard here again, let's say this here, of course, is our ball, and it has a velocity of 6. That means it's moving this direction 6 pixels, and then this direction 6 pixels. So it will wind up kind of here after 1 frame, and then it will keep doing that every single frame. That's what we want to happen. So we want to just make the ball move every frame. And that's actually surprisingly easy to do. So all we need to do is in move here is we need to, as I mentioned, we have this self.rect. And if we move the self.rect to a new place, it will actually move where the ball appears on the screen. So we can say self.rect.x, and this will plus equals self.velocity x. And this says take our x velocity and add it to our x position. So we're doing this stage here where we take our x position, which is this area here, and add 6 to it to move it here. And then we're going to do the same thing for the y. So we're going to take self.rect.y and add our self.velocity.y to it. So we are now moving it from here to here. So this means every single time we call the ball.move method, it will move the ball. So let's try that. Down here in our while true loop, main.py pygame.init. I would assume you're not importing pygame at the top, if that's happening. It thinks pygame.init doesn't exist. So at the very first thing you need to do is make sure you're importing pygame. And as I mentioned at the start, this will only work if you are on a pygame trinket. So when you make a new trinket, make sure you're making a pygame trinket here, not just a normal Python one. Otherwise, it unfortunately won't work. That's just one of the quirks of trinket. Okay, and if it still doesn't work, share your code, and of course, one of the helpers will help you. So down here in our while true loop, every time the game runs now, before we draw the ball, we want to move the ball. So we're going to say ball.move. And this will just say, okay, move the ball as intended, and then redraw it. So ideally, when we run this now, okay, so we're now going to run this, and you can see, oh, it went kind of quickly there. So let's slow it down a little bit by moving our velocity down to 2 and 2 for now. You can see the ball appears on screen and then moves, right? Which is great. However, it just kind of flies off the screen and then never comes back, which is not what we want it to do. We want it to kind of bounce around the screen, right? So let's do that. Let's make it bounce around the screen. And we can do that by doing some very simple math. So again, let's look at our lovely whiteboard here. And let's say that our ball, if your ball isn't showing on the screen, make sure you're calling ball.group.draw here. And of course, that your ball is in the group to make sure it shows up on the screen. This needs to be within your while true loop. So let's say we have our ball here. So let's say a ball's here, and it's going to hit this wall like so. And when it hits this wall, we want it to bounce off like this. So if our ball is traveling to the right, it has a positive x velocity. And if it's traveling to the left, it has a negative x velocity. Similarly, if it's traveling up, it has a negative y velocity. And if it's traveling down, it has a positive y velocity, because the numbers are going up when it's going down, so it's a positive velocity. So we can think about that as, quite simply, when our ball hits the side of the screen here and then goes this way, what's happening is our y velocity is staying the same. It keeps going up, but our x velocity is changing. It starts off going right here, but it ends up going left. So if the ball hits the side of the screen, our x velocity will become negative or positive. Similarly, if our ball hits the top of the screen, up here, let's say, it hits it like this and then bounces off like so, our x velocity stays the same. It keeps traveling the same direction across the x-axis, but the y velocity starts going up but finishes coming down. And we can do that by simply checking where the ball is on the screen and then making a change to it. So in our ball move here, before we make any changes to where the ball is, we can check where the ball is. So before we go any further, I'm going to paste a link to my code that everyone can just use to get everyone into a state where we have a working version of the game. So let's save this. Let's post a link. So this link I'm posting will be a currently working version of the game. We'll get everyone onto the same page now. So we will all have a ball that's on the screen and just flying off the screen when you run it. Okay, so that will get everyone into the same situation here where we have working code. I'll give you a moment to open that. And we will continue. So you will now have the same thing as me. Now we're actually going to make the ball hit the wall and bounce off. This is where it's going to get quite exciting. So before we actually move the ball, we're going to check where the ball is on the screen. So we can say if self.rect.x, this is if the x position of the ball is greater than 600, meaning if it's off to the right-hand side, or self.rect.x is less than or equal to 0, meaning it's hitting the left-hand side of the wall, self.velocity x will equal negative self.velocity x. And this just says if we have a positive velocity, make it negative. And if we have a negative velocity, make it positive. And we can do the exact same thing here, except replacing all of the x's with y's. So I'll let you take a look at that, get this written out. But this is basically saying now, if we hit a wall, make the ball bounce. So let's run it and see if it works. You can see now our ball is in fact hitting the walls and bouncing around. So I'm going to speed the ball up a bit and rerun it. We can see now the ball is actually hitting the walls and bouncing around, which is what we want. So we have one of our key aspects of this game finished now. The ball is bouncing around. Now we want to make some way for our player to actually hit the ball with the paddle, right? And so this is where we're now going to make our paddle. So the first thing to do is copy the first, let's say, 6 lines, 7 lines even, of the ball. So you can just take all of this from the class down to self.rect.center and copy it. And then paste it above the ball like so. And then we just change the name ball here to paddle. And we now already have a paddle object that exists in the game. We're going to change some of the attributes. So we're going to say, let's say the surface will be 100 by 15, which will give us that very rectangular paddle look. And we're going to change the position to, let's say we're going to change the position to 550 here. 300 by 550. So our paddle will appear towards the bottom of the screen. But of course, if we run the game, the paddle won't appear. We'll still only have the ball, because we now need to make the paddle actually appear. So back down in our section here where we're building the game, we're going to do the same thing, just copy all of this code and replace the word ball with the word paddle. And this will allow us to actually make a paddle and add it to a group of other paddles. Okay, I'll try to slow down, but we are halfway through this now, unfortunately, and we've only got the ball working. So the code will always be on screen, so you can of course always copy it, and I will periodically be pasting the links into the chat so you can see how it goes. But I apologize that I can't slow down much more if we want to finish it. Okay, but now we can say here, okay, we can do paddle underscore group dot draw to the screen in our while true loop here. And this should now, if we run it, have a paddle appear on the screen. So now we just have to make the paddle controllable, right? So this means now we need to look at where the mouse is on the screen and move the paddle to it. So before we can do that, at the start of our while true loop, we need to do event equals pygame.event.poll. And this is a bit of code that just tells Pygame, okay, look at the mouse and look at the keyboard, look at everything our player has done, look at everything that has changed, and remember it. So if we move the mouse around the screen, this line of code will now know that the mouse has been moved. So if we go up to our paddle again here, and we say def.move, we're going to make a move function for the paddle. And then we can say, okay, the first thing we need to do to move the paddle is look at where the mouse is on the screen. So we're just going to make a variable here called mouse. And this is going to be pygame.mouse.get_pos. And we're going to put square brackets 0 here, which just says get the first returned value from here, which basically says get where the mouse is on the x-axis. So when we move the mouse left and right, the paddle will follow. And now we're actually going to update the paddle to go to where the mouse is. So similar to the ball, we can call self.rect.x equals mouse. And this will say, move the paddle to where the mouse is. So if we run this, it's not working because I'm not calling paddle.move here. Yep, I'll update the link now. It's actually good to update the link here because we now have a moving paddle. Okay. So if we run the game now, we have our paddle following our mouse. But as you can see, it's kind of off-center. The mouse is on the left-hand side of the paddle. So what we can do, because we know our paddle is 100 pixels wide, we can just say mouse minus 50, which means shift it to the left by 50 pixels. And then we are now in the middle. So we have our paddle that we can move around, and we have our ball bouncing around. The last thing to do is make it so that if the ball hits the paddle, the ball bounces off of it, because that's what we want to happen, right? We want to interact with the ball. And we're going to do that actually in the ball here. So like I said, the ball move function is going to start getting quite complex. And we're going to do it between where we check the walls and where we move it. So we're now here, after checking the walls, going to check if we're hitting a paddle. And Pygame has a really nice function to do this. So this is quite a long bit of code, and I will paste this bit of code into the chat so you can see it. But we're going to say Pygame, no, if Pygame.sprite.sprite collide. So this says check if two sprites are touching each other. And we're going to pass in the two sprites we want to check. We want to check if if the ball is colliding with anything inside the paddle group. So this says, okay, if the ball is connecting with the paddle, we then need to pass in a third variable. This is just false. This says we don't want to destroy anything. So this line of code here, I'm going to paste this into the chat. So you don't have to kind of copy all of that out. This line of code here says, if our ball is connecting with a paddle. And let's take a look at our whiteboard again to think about the behavior we want our ball to have. So if we have our paddle here, that's a really awful rectangle. There we go. And let's say we have our ball here. And our ball is going to come down like so and hit the paddle and bounce off. Okay? What is happening here? Well, the x-axis, we're traveling the same direction left and right. We stay traveling left, but our y velocity changes. So we start going down, but we end going up. And it's the same if we come from the left here. We bounce down, we bounce up, but we keep moving to the right. So that means the only thing that happens when our ball touches our paddle is our y velocity inverts. And of course, we've already done that, right? So we can just copy this line of code from here, where our y velocity inverts itself if the two are touching each other. So if we run this now, ideally, we can see the ball is bouncing off of the paddle, which is what we want. So we now actually have a nice little interactive game. We have a game here, a thing is happening. However, we don't want the game to just start right away, and we want something to happen if the ball falls off the bottom of the screen, right? So we are going to add a new variable above the ball here, just called launched, and we're going to make this false. And this says the ball isn't launched yet. And then in the move function here, update the link, okay? Save. Link copy. There we go. Okay. So if the ball is moved here, we only want the ball to move if launched is true. So we're going to say if launched here, highlight all of this and hit tab once, and it will indent it all to only happen if launched is true, which it isn't at the moment. So now we want the user to be able to tell the ball to launch by, let's say, clicking the mouse. So if we go down to our running the game section here, we can make that happen. We can say if event equals, and this is, I've got to look at my bit of code here. Here we go. Pygame dot all capital letters mouse button down. So this says if the user clicks the mouse, launched will equal true. So now when we run the game, our ball isn't launched yet, but as soon as we click the mouse, it's not working because I've made a mistake quite clearly. Launch, of course, we need to make sure we have here global launched. I'm fairly sure that's the problem. Nope, Pygame is not. Oh, it's on line 62. It needs to be event.type, just like so. And now it will work. There we go. So we left click the mouse and our ball starts bouncing around. And before I share the link one more time, we're going to make one other thing happen. If the ball falls to the bottom of the screen, we want the game to stop because we don't want the user to be able to miss the ball. So if we miss the ball here and it falls off the bottom, we want, of course, the game to stop here. So what we can do in our ball move function here is, first of all, take the first condition out of our y here, and instead say, if that happens, if we do fall off the bottom of the screen, launched will equal false. Okay? So now, if our ball does fall off the bottom of the screen, yeah, I will update the link very shortly. Launch will equal false. And then we need to say here, if launch does equal false, we're just going to give it a position here to make the ball. I'm going to just put this line of code here and then share the link with you. Starts falling down when the game starts. So if it starts falling down when the game starts, you can make your y velocity on line 31 here be -6. And if that's negative, the ball will actually start going up. So that's one thing you can do. So now if we run this, our ball will start on the paddle. And when we left click, our ball will now start bouncing around. If it falls off the bottom, it comes back to the paddle. And now I'm going to share this bit of code because we now have everything working with one exception. We don't have any bricks. Breakout is about breaking bricks. We need to break some bricks. We need some bricks to break. So we're going to make some bricks to break. And this is going to be quite simple. So at the bottom here, after we make our ball class, we are now going to make a new class. And again, we're going to copy the first few lines of code from the ball because we can just keep reusing this. Paste it here and replace ball with brick. And the beautiful thing about this is that we now, again, have another object we can use. I'm going to change some of the values. We're going to make it 80 by 40 to give it that very brick shape. And then we're going to in our def in itself here on line 51, we're going to ask for some more variables. We're going to ask for X position and Y position. And we'll see why later, but we'll just put that there. And then we're going to pass those X positions and our Y positions into our class. So now when we create a brick, we can tell the brick where to appear on screen. And we can even then make it appear there, here, which is all we're doing. And our brick is now actually complete. We have to do nothing else to our brick. It's fantastic. So in our building the game section now, we need to make our bricks appear on the screen. So we're going to do that by just making, of course, first of all, a brick group. We've done this before. And now we're going to say brick underscore group dot add. And we're going to add in a new brick. And we're going to pass in two variables, 100 and 100. This says, create a new brick, place it at position 100, 100 on the screen. And of course, add that to the group of bricks. So we can make sure we can check if the ball is hitting things. And then, of course, as we've done before, down here in our loop, we're going to call brick group dot draw. And now if we run this, we should have our brick appearing on the screen. There we go. And we can copy and paste this line of code. And we can just change these values to change where the brick appears. The class after brick. There we go. So there's the class of brick for you on screen. So I'll let you look at that while we run the bit of code that we have. And you can see now we have 5 bricks appearing on the screen in the places that we have told them to appear, which is wonderful. But our ball hits them and nothing happens. So we need to make that happen now. And for that to happen, we need to, again, do a bit more math. There's lots of math involved in game design. Anyone who wants to make games will learn there's a lot of math involved. And we're going to do that now. So let's say we have our brick here. And we have our ball. It's going to be here. And our ball is going to connect with this brick like so. The brick is going to go poof, and the ball is going to bounce away. This is where we get a bit tricky, because if our ball hits the bottom of the brick, it starts going up and then goes down. So we invert our y-axis. But if the ball is over here, and then it hits this side and bounces off this way, well, here we're going from left to right. So actually here, our x-axis is inverting, right? So we need to be able to tell which side we're hitting the brick on. So we don't have much time left. I'm probably going to run a bit over time here, and I apologize. But we're going to just get this final part working where we're breaking our bricks. So we can do this by doing one simple thing. We can move the ball up and then check if it's hitting a brick. And if it is, we know we're hitting the bottom. Optionally, we can move the ball left first. And if we're not hitting something here, we know we're not hitting the sides. But if the ball is over here and we move it to the left first and then check, we know it's hitting the brick. But if we move it up and then check, we know it's not hitting the brick here. So if we move it left and right first and check if it's hitting a brick, and then move it up and down second, and then check if it's hitting a brick, this way we can determine if we're hitting the bottom or the top, and it will bounce accordingly. So we're going to go back into our ball class here. And this is again happening in the move of the ball class. So here I'm going to share the code one more time now before we make this last part. And then we're going to program our brick logic. So with this line of code, with this bit of code I'm going to paste, you will have a ball bouncing around. You can hit with your paddle and some bricks appearing on the screen that nothing happens to. Now we are going to do the last part where here on line 45, after we move it to the left and the right, we're going to check if it's hitting a brick. So we can use this bit of code here that we've already used, change paddle group for brick group. And we can change this false here to true. And this true says, if we do hit a brick, take it off the screen, delete it, right? Because this way, when we hit a brick, we're deleting it. And we can say self.velocity x, which we've already got up here, will equal negative self.velocity x. And we can just copy all of this code here. It's a lot of repetition, and paste it down here. And again, use this to invert the y-axis. So this is now saying if the ball is hitting a brick, it will invert depending on where it hits the brick, and it will delete the brick. So in an ideal world, we're going to run this now, and we will start breaking bricks when we hit them. Look at that. We actually have, technically speaking, a finished game of Breakout now. However, there's one small thing. One last thing I want to do to this before I leave you off. And that's that when we destroy all of the bricks, they don't come back. So let's make that happen. So in our building the game section down here, we are going to put all of this creation of bricks into a function we can call, and then we're going to call the function immediately. But what this means is anytime in the game, we can make this happen again. So we're going to do that. We're going to, in our ball move here, if the ball hits the paddle here, so when we've destroyed all of the bricks, the ball's going to come back down to the paddle. And if it hits the paddle and our length, our brick group is less than or equal to 0, meaning there are no bricks left, we're going to make launched equal false, so the ball will stop moving. And then we're going to just call create bricks. And if we do this now and run it, and we now break all of the bricks, assuming I've done this correctly, we will break all of our bricks. This one's going to be hard to get, isn't it? Oh, nearly got it there, this time for sure. There we go. The ball's going to come down, the ball's going to stop, and bricks are going to reappear. So we've got a couple minutes. So the last thing I'm going to do here is in our create bricks method here, I'm going to just create 2 more rows of bricks by incrementing our y-axis by 50 at a time, where the bricks appear. Just like so. So now if we run the game, we have Breakout. We've finished making Breakout. So I'm going to post this last bit of code to you, and I'm going to give you a challenge to work on in your own time. So here's the last bit of code, and I'm going to issue you all a challenge to work on in your own time now. Think about this, and think about our brick constructor here. If we wanted every brick that appears to be a different color, what would we do? And then if we wanted to implement a scoring system, if we wanted to track the score of the player so they get 1 point every time they break a brick, how would we do that? So I want you to think about those kinds of things, and it will get you thinking about some very simple game development ideas. How would we make the bricks a different color, and how would we track the score of the user if, for instance, they were to get a point every time they hit a brick? But for now, I'm going to leave you with this. We have our working game of Breakout here. I'm going to play it for you just for a couple of seconds before I hand back off here. And yeah, so hopefully you guys have all enjoyed making your own game here in Python, using an object-oriented approach. And also, one last thing to think about. Let's say every time you hit a brick, you want the ball to get faster. How would you do that? What variables do you need to change, and when do you need to change them? Think about that kind of stuff, and maybe if the link above CoderPerson1234 will have all of the code for you. So think about that, and maybe next time I see you, we will look at this same game of Breakout, but add a lot more new features to it. So thank you all very much, and I'm going to be passing back off to Peter now, assuming Peter's around still. There we go.
Thank you so much. That was just a feast and a delight of virtuoso wizard programming. And I think the youngsters will love experimenting with the challenges and all the pointers that you gave them. Thanks so much. So Aya, and also Jonathan and Richard. Richard, I don't know if I think Jonathan's had to drop out. Richard, maybe you're there in the studio to say goodbye with Aya and me for the afternoon. It's been absolutely fantastic. And I hope you all enjoyed it. And we hope to see you again before too long. So, Richard, a brilliant afternoon. I think it was just fantastic. Thank you for staging it and for the amazing face filtering, which was hysterical. I loved it. And Aya's game and Jonathan's complex and challenging Tour de France. What an afternoon. Excellent. So thanks to everyone. I hope you all enjoyed it at home, and see you again before too long. Meanwhile, stay safe and enjoy the sunshine. Bye.
Bye, everyone.
Bye, everyone.